Assalamu alaikum. In this video we are going to analyze how we can resolve the multicollinearity issue. As we have analyzed the detection method for multicollinearity in the previous video, in this video I'll show you how to resolve the multicollinearity issue. There are several methods to resolve the multicollinearity issue, so I'll explain the methods one by one. To remove the multicollinearity, there are different ways. Following are the ways to remove multicollinearity. First method is to do nothing. This is because those variables might be an important factor in your study, and the multicollinearity issue might not make a disturbance in your results, so you don't need to do anything. Next method is to transform the correlated variable. This is the method. This method shows that we can transform that variable which is highly correlated in order to normalize our result. I can show you in this data. For this I'm using the same data set of city temperature 4 from the exemplary data sets of Stata, and what you need to do is you need to transform the variable, right? So I am processing the regression model. This was the model in the previous video I have used. I am using the same video, and I'll show you again that there was a high correlation of the cooled variable, so we need to transform this variable. For this you need to check the transform method significance of this variable from the ladder command, and ladder command shows that you can transform it into these 4 methods, which is cubic, square, identity and square root, because these are showing the significance. Rest of the methods are not showing significance for this variable. You can visualize this through graphical representation from the command gladder and select the variable, and here you can see that the graphical representation of the variable from the transformation method. You can see that cubic and square are not good choice for the transformation method. Identity is the original variable and it is also not normal, so we can use square root to some extent. So let's transform the variable into square root of the variable. For this the command is gen. Rename your variable. I am renaming it as sqrt cool is equals to, you need to simply copy this formula and paste it over here, or you can write sqrt bracket open, select your variable and bracket close, press enter, and a new variable have been generated which is the square root of your variable. Now let's process the regression model with this variable. You need to select the dependent variable. Now select the transformed variable and rest of the 2 variables for the regression model, and now you need to check the multicollinearity, and now you can see from the results that it is now more highly correlated as it was previously, so the transformation method is not applicable for this variable. Let's move on to another method, that is drop the redundant variable. The next option we can choose is to drop the highly correlated variable from the model, because we have no other choice since it is highly correlated after transformation. So what you need to do is you just need to drop this variable completely. You don't need to add a transformed variable over here. You can completely drop this variable and process the regression model, then check the multicollinearity, and now you can see a major change in the variance inflation factor value, that it dropped from 5 to 1, which means that variable was creating the issue of multicollinearity among the variables and your model. However, if you are not able to drop your variable from the model due to your research perspective or any other point, you can just need to increase the sample size, because this is last but not the least option in order to spread the correlation among the other variables you add and observations you add. So either you can add a new variable or increase the sample size to avoid the multicollinearity issue. These are the methods to remove the multicollinearity from your data set. Hope you liked the video. Thank you and Allah Hafiz.